say the three possible solutions. Mm-hmm. We can get a no solution, we can get an infinity, or we can get an ordered pair. What does it mean when your answer is no solution? Parallel lines. You have two lines that never meet. So there's no solution that makes them both true. What do I mean when it's infinite solutions?
They're the same.
Right. When you go to graph them, I've given you two equations for the same thing. What do you get an ordered pair? Right. Two lines that intersect. So either they meet and your solution is an ordered pair, they're parallel and we get no solution, or they're the same line. We have infinite solutions. Alright, so with these, what do we have to do to be able to graph them? So we have 2y equals negative 3x minus 8. Divide everything by 2. So y equals negative 3 halves x minus 4. Okay. I don't know why mine is missing some grid lines. Okay. Second one. If I subtract my x, divide by negative 1, I get y equals x plus 1. So slope is 1, up 1 over 1. So my solution on this one is? How many of you got that? Next one. First one, we subtract our x. Divide by negative 4. So y equals 1/4 x minus 2. Right, 2, and we can go up 1, over 4, or down 1, and back 4. Alright, second line is y equals 1/4 x plus 3. So we start at 3, 1 over 4. So what's true about these? No solution. Is there a way you could know they were parallel before you graphed them? Same slope there. So we know they're going to be parallel. We know there will be no solution when we graph them. Okay. So what's the downside to solving these things by graphing? Has to be perfect. You can't mess up. Even if your dot's just slightly off, it can really change your answer. So we need some other options. If you would go to your binders, we should be on the next notes page now. So we've looked at the graphing. Basically, you look at a graph, find the points where they meet. That's your solution. Substitution is a method of solving systems by substituting equations into one another. So we're going to do it using what we know about solving equations instead of what we know about graphing. So to do this, we have to take one of the equations and solve it for either x or y. It will not matter which equation or which variable, but you want one of the equations to be x equals something or y equals something. Step 2, we will substitute this equation into the other and solve for the variable. Then we will substitute our answer into the revised equation from step 1 and solve for the other variable. Here's what I mean by this. Let's look at an example. We have to solve one equation for either x or y. It doesn't really matter on this one, they're both y equals. So let's just say I'm taking the first one. Y is 4x minus 1. I'm going to substitute that into the second equation. Okay, so the second equation, instead of this y, what could I put? Y is 4x minus 1. So the first equation, I knew what y was. I took that and replaced the y in the second equation. Can we solve this equation? Yeah. So subtract our 2 out. The 1. Divide by 2. So x is negative 2. Okay. So we found we had y equals, we substitute that into this other equation and solve. Now we're going to take our answer and really we can sub it in either place. So let's just go back to that first equation. Y was 4x minus 1. But now I know that x is negative 2, so I'm going to plug in negative 2 for my x. Does everybody know what I did there? So if we solve that, y equals negative 9. And how do we write our final answer? Order pair, x comma y. So this is a little more accurate than graphing. Our graph doesn't have to be perfect. It will allow us to find not pretty answers just by solving our equations. Any questions on what I did there? Number 2. So one of the equations has to be x equals or y equals. And the first one is. It tells me y equals 6x. So what I'm going to do is take that and sub it into the second equation. So we have 2x plus 3 times y But what are we plugging in for y? So 3 times 6x would be 18x. 2x plus 18x is 20x. Divide. And x is -1. Once we have x, we can plug it into either of these equations. Let's just go with the first one though. It was y equals 6x. But if my x is -1, then my y is -6. So my answer is -1, -6. Is everybody okay with that? It's the third one. I need one of the equations to be either x equals or y equals. And we have that. So in the first equation, my y is x plus 9. So I'm going to plug that into the second one. Now, very carefully, watch how I write this, because I don't want you to make a mistake here. We have 3x plus 8, and I'm replacing my y with x plus 9. What do I have to do with that 8? Distribute it. So does everyone see why I put those parentheses there? Because I have to take the whole thing times 8. So I get 3x plus 8x plus 72 equals -5. These are on the same side, so we just add them. We subtract that. Divide by 11. And x is -7. Where would you plug that in to get your y? Mm-hmm. So I replace my x with a -7. -7 plus 9 is 2. So my lower pair is -7 too. I want you guys to try number 4. X is 4y plus 7. So it says replace that x with 4y plus 7. So what do we have to do next? Distribute the 2. Okay, 8y minus 6y. So if we subtract over the 56, divide by, hold on, what did I do? I distributed, yeah, I think I distributed an 8 instead of a 2 right there, for some reason.
I was about to say, what did I do?
Nope, I just turned my 2 into an 8. How about 8y plus 14. Okay, let's subtract our 14. So 2y equals negative 2. Divide by 2, so y is negative 1. So now we can plug it back in. We said x was 4y plus 7. So y is negative 1. And so we get 3. Make sure when you go to write your ordered pairs, it's alphabetical, x comma y. So my x was 3, my y was negative 1. You have to watch that when you plug them in. Are there questions there? We're stopping here today. Listen carefully. I'm giving you a handout, but we are not ready to do the whole thing yet.
X equals 4.
Alright, on this handout, I want you to do the front side only. So that's 1 through 8. That is all we are doing right now. Don't lose it. We're going to do the other side tomorrow. But today it's 1 through 8.
Yeah. Only 8 probably.